All right, good morning, everyone. Welcome to our last class. So before we go into the last topic, ethics of artificial intelligence, we will conduct a small quiz on the minimax and alpha-beta pruning, a simple quiz to assess whether you already have a good understanding of the minimax and alpha-beta pruning the topics. So you can join this quiz by scanning this QR code, or you can also join this quiz by typing the code here, 67710062. And we can take a few minutes to scan this code. All right, so has everybody joined? All right, then maybe we will start this quiz. So start with question 1. So you can type some of your nickname. Okay, so let's see the question 1. Okay, great. I think most of you can get the correct answer. This is false. If you have already played with the AI in the tic-tac-toe game in Google Cloud, you will find that actually you can reach a draw, the game draw, instead of always letting the AI win. So if you also play optimally, actually you can just force the AI to reach the draw. So this is not true. This statement is false. AI does not definitely win because you can also play optimally with the AI. Okay, so let's check the leaderboard. Okay, thank you. Okay, Carl Gustav is our number 1. Okay, the midterm below me is still here. Okay. Okay, and thank you for being my fans. Then let's see the question 2. Okay, good. So this is true. Alpha-beta pruning, yes, it can be applied at any depth of a tree, as long as the pruning condition is satisfied, that is alpha larger than or equal to beta. As long as this condition is satisfied, then we can directly prune all the remaining children of the node. All the remaining children, of course, they are not only tree leaves. They can also be some entire subtree under some nodes. So this is true. Okay, check the leaderboard. Okay, Carl Gustav still on number 1. And let's check the question 3. Okay, this is true. So basically, that's why we can apply alpha beta pruning, right? We apply alpha beta pruning because we want to maintain the efficiency. In the meantime, we need to still make sure alpha beta pruning is an optimal algorithm. Optimal algorithm means that the final decision is still the best action AI can take. So that means all the nodes removed by alpha beta pruning, they definitely won't affect the final decision because the nodes pruned, they are not some best actions, and they are just some unnecessary nodes and branches that are not worth exploring. So that's why we can prune these nodes. The motivation of alpha beta pruning. So this statement is true. We have a hula hoop. Okay, hula hoop is our number one. Then we check the next. This is a little bit tricky. This is false. So when we do the backtracking in-depth first search, only the node value will be passed to the parent node. Alpha and beta, they will only be passed from parent node to child node, and alpha and beta will get updated when the node value is updated. So that's why this is false. The node value, basically this part is correct. Node value will be passed to the parent node, but alpha and beta, they will not be passed to the parent node. Alpha beta get updated only after the node itself get updated of its value, and alpha and beta, they will be passed from parent to node, to child node. So that's why this is false. So yes, so a little bit tricky, so please pay attention to that. The node value, alpha value, and beta value, they are in different passing mechanism in the alpha beta pruning. So let's see, since this one is a little bit tricky, maybe we will change the ranking now. Okay, hidden is our number one now. Then let's check the final question. Okay, it should be only zero-sum games. Minimax and alpha beta pruning, by this algorithm, they already assume that the two players, max and min, they are fighting against each other, right? They are definitely in strict competitive relation. That is equivalent to say the game must be some zero-sum game. Max and min, they have like just right opposite goal in this game. Max trying to maximize the score, while the min player try to minimize the score. So they are just fight against each other. So can only be applied in zero-sum games. Now that if it's some non-zero-sum games, then alpha, beta, pruning, and minimax, these two algorithms cannot get the optimal action. They cannot get optimal action. Basically, they're just some non-optimal algorithm, and it's useless to play some non-zero-sum game. So when we're saying that, okay, we want to apply these two algorithms, then already assume that there are some two-player zero-sum games. So that's why we select the first option. Let's check the final leaderboard. Okay, yeah, congratulations to Sebastian. Sebastian here. Okay, don't know who is this guy. But I think it's not the first time that Sebastian be the champion. I remember maybe previously Sebastian also. Yeah, very good. All right, so that's some simple questions about the basic concept of the minimax and alpha beta pruning. So any questions so far regarding these problems? Great. If no question, then we can start today's new topic. That's our very last topic, the ethics of artificial intelligence. After the whole semester, actually, we are learning the algorithm, the models of the artificial intelligence. So basically, we already know some very important, very classical models. We know the technical details. We know how to apply them. We know what they can be used to do. But still, we need to explore more on the ethics. That is the ethics to apply, to design about the models, and also what implications these models will brought to our society. So we go into the AI ethics, the last topic. So AI ethics is a term that refers to the ethic issues surrounding the use of the AI technology. Of course, the term ethics is a very old term, right? It's from some ancient Greek time. But now, when it emerging with the AI, we specifically care about the ethic issues in the AI field. So as the use of the AI systems becomes more prevalent across the globe, then the governments, industry groups, and the AI-focused executives, they are grappling with how to ensure the technology is used ethically. The technology is very, very powerful. We already know that AI is powerful. So how to constrain and how to make sure such powerful strength is used ethically is very, very important, especially with considering that now the AI systems affect everybody. Not only the one like who are learning AI like us, actually those people who are outside the AI community, they will also get affected by the AI systems. So the AI ethics is about the technology change and its impact on individual lives, but also about the transformations in society. Then the definition of AI ethics. So possibly different people will have different definitions. Here we adopt the UK's Alan Turing Institute definition of AI ethics. They define AI ethics as a set of values, principles, and techniques that employ widely accepted standards of right and wrong to guide the development and use of AI technologies. So in practice, this means ensuring that the organizations using AI have the right AI ethics policy. Here the right is more like a moral concept, right? That is correct, what is correct to do, what is right to do, instead of the legal concept. We know that in legal concept, we also have the rights. Basically, that you have the rights to do something. Here, the ethics, we only talk about the moral concept of rights. So have the right AI ethics policy and governance practices to ensure the technology is used for good and does not unintentionally harm people. And there are some key questions in the field of AI ethics, the researchers and also the ethicists they want to address. The first key question, what are applications for AI systems ethical for a given organization? We have to first know what is ethical. And then how can the companies ensure the AI systems are built to operate in a fair and unbiased way? Later on, we will specifically address this concept, fairness and bias of AI models. The third key question, what processes do companies need to ensure the AI systems continue to function ethically over time? This is more about the robustness, the safety of the AI models. Then what are the potential harms that AI systems may cause? Right? Why should we learn about the AI ethics? Are there any practical harms? Yes, actually there are many. Maybe sometimes we just omit the harms, but actually they just exist in our society. For example, invading people's right to privacy. Here, this right is a legal concept of rights. We know that ideally everyone should have the right to privacy, but using the AI systems can easily invade people's such privacy rights by processing the data without consent or just handling it in a way that reveals personal information without an individual's consent. Consent is a very important mechanism and important concept in the privacy. For example, when you download an app in your smartphone, and before you start to use it, it always asks you to agree to the user consent, right? But I guess you're just like me, like no one has really read what is the user consent, what is the terms of use, because it's just a long documentation. But actually, that long documentation decides how the apps, how the companies can just process your data, can store your data, and maybe even share your data with the third party. But due to like it's such a long, actually the consent, even though like legally speaking, they exist. Right? We all agreed they use our data by agreeing to the consent. But it seems that practically it's just easily invaded because no one has really read the consent. And second possible harm is that the AI may just make some biased or unfair decisions or recommendations about the certain populations or demographics. And this is specifically about the fairness and bias. Later on, we will stress this. And the AI may also like just make decisions in a way that can't be explained in plain language. So it is unclear if their conclusions are fair and unbiased. And this is specifically about transparency and explainability about the AI. Actually, many AI models, specifically neural networks, deep learning models, are criticized being the black box model. The black box model is that we know there is a neural network, and there are some input to the neural network, and then after so many layers, neurons, they will predict some output. But all the calculations inside the hidden layers inside the neural network, actually they can't be explained. That's why people criticize them as the black box model. And know that now it's not only for some non-experts. Definitely the non-experts who never learned AI, they cannot understand what happens in a neural network. But even for the people who work at the AI field, it's still very hard to explain, right? For example, in PA2, you build MLP, you build CNN, right, to predict something. But what if I ask you, like, what exactly are these neurons used for? What exactly is this calculation? What exactly does this parameter means, represent? Actually, it's very hard to answer. You can't answer that, even though you built the model by yourself, but still you cannot explain what exactly happens inside your neural network. And like then what about the other people, right? What if I ask you to explain to some non-experts? Then it's even harder because basically they don't know any techniques. That's about the transparency and explainability issues in the AI models. And another possible harm is that AI sometimes make the unreliable decisions or deliver the poor quality outcomes due to the model implementation issues. And I think the one of the most intuitive examples nowadays is the AI hallucinations. We know that when we use the generative AI models, the generative AI models just sometimes output with some severe hallucinations, right? Their answers may just doesn't make any sense. These are some unreliable decisions and some poor quality outcomes. And actually, some researchers prove that from the mathematic sense, the AI hallucinations cannot be avoided due to some statistic issues. And then the last possible harm, denying people their right to accountability for the decisions AI systems make about them. This also related with transparency and explainability. If people can't explain what happens in an AI model, why the AI just gets some decisions, basically this is denying people's right to accountability for the decision, even though the people just get affected by the decisions made by AI. For example, if we use AI to hire people for recruitment, and then that means all the applicants, they will be decided whether they get hired by an AI model, or at least at early stage, possibly the CVs of the applicants will get filtered by the AI system. In this case, the AI made some very crucial decisions, but still it remains unaccountable about the people's rights. Then you may ask, is AI ethical? Right? We want to build some ethical AI, definitely ethical and responsible AI, but is AI ethical? Note that the AI technology itself does not have any subjective. At least for now, we don't hold the AI technology itself has any subjective. So the AI technology itself is neither ethical nor unethical. Like in philosophy, in ethics, they don't have such ability to be ethical or unethical. Instead, the enterprises who build the AI models, who use the AI models, must establish the principles or frameworks to ensure that they use the AI systems ethically and responsibly and guard against the AI misuse. But still, there are many problems, like if we require the enterprises to establish such frameworks to ensure the AI is used ethically, then actually there is no consensus about what ethical responsibilities enterprises have for different applications for AI technology. And also, different AI-focused executives can look at the same use case for AI, but in the meantime, they will draw different conclusions about their moral responsibilities. That is, the consensus is very difficult to reach, especially when we are considering there are many stakeholders involved with the same AI system. And also, there are many ethical dilemmas associated with AI use. For example, deciding whose lives the autonomous vehicle should prioritize saving in a multi-person crash situations. This is a very classical dilemma, right? We know basically this originates from the trolley problem, like who to save when there is like definitely an accident to happen, who to save. And the autonomous vehicles, that the self-driving cars sometimes will just meet such dilemma. And also, some dilemma involves like ensuring that credit scoring AIs do not discriminate against people unfairly based on factors such as gender or maybe some other factors such as race. Because currently, already like some banking systems, actually they are used the AI models to do this credit scoring, like to measure what is the credit score of each applicant. In this case, it seems that one of the possible solutions is to build the AI principles and some common grounds so that at least we can build up some consensus and then let the individuals, let the institutions to follow. So in the last few years, there are a number of institutions, they have published their AI principles, like some famous ones, ACM published it in 2017, IEEE also published in 2017, and UK House of Lords published it in 2018, and also the Ethic Guidelines for Trustworthy AI by European Commission published in 2019, and the Google actually published in 2019 and updated it almost every year. So there are, we have seen there is emergence of the AI principles. Each different institution may have some differences in their own AI principles. So here we will look at the 7 European Union principles. I think this is one of the most widely accepted and commonly adopted principles. In the 7 European Union principles, the first one is about human agency and oversight. So in this aspect, AI systems should empower human beings, allowing them to make the informed decisions. The second would be the technical robustness and safety. In this aspect, AI systems need to be resilient and secure. They need to be safe, ensuring a fallback plan if something goes wrong. Then thirdly, privacy and data governance, also very important about every user. So besides ensuring full respect for privacy and data protection, ethical data governance mechanisms must also be ensured. Then the first, transparency. The data system and AI business model should be transparent to the public. Then the fifth, about diversity, non-discrimination, and fairness. The unfair bias must be avoided in the AI model. The sixth would be societal and environmental well-being. The AI system should benefit all human beings. Then, last but not the least, accountability. The mechanisms should be implemented to ensure the responsibility and accountability for AI systems. So actually, I also omit many long descriptions, text descriptions about each of the principle. I just kept some very brief introduction and explanation here. So there are many different lists of principles, like different institutions, different conferences. They may have their own principles, but it seems that they can be synthesized into 5 fundamental principles, and we call them common grounds. So we have 5 common grounds like this. First, about autonomy. Autonomy means the people's autonomy, of course, not AI's autonomy. The people should be able to make their own decisions. For example, when we are building the AI models, especially which used to do the crucial decisions, we need to ensure that human in the loop. So that is, the AI should function under the people's supervision. So this is the human in the loop, and also to ensure the privacy protection. The second common ground is the beneficence. Society at large should benefit from the AI models. Third is about the non-maleficence. That means the AI cannot be used by some malicious intention. The harmful consequences should be avoided. For example, the system should be robust in order to ensure the safety. And then justice. So justice is more about the diversity, non-discrimination, and fairness. Then last, explicability. That's about the transparency and explainability of the AI model, especially the very complicated model. So we introduced some principles, some common grounds, but this is not a perfect solution to address the AI ethics issues. Still, there are many limitations and problems with the principles. Of course, it is good to state principles, right? However, they also create new problems, since all the principles in the previous 2 pages, they are just very high level. They are just very abstract principles. They do not address some very detailed case. They do not address any specific real-world situations. In this case, they can be interpreted in different ways. For example, consider the autonomous killer drones, the killing machine. Definitely, there are some not ethical application, right? Because but in the other sense, some people think that these autonomous killer drones can be considered beneficial for the soldiers, because actually they can just save the lives of the soldiers. They can reduce some deaths of the soldiers if just use the killing machines to do this military usage. But the majority still think that autonomous killer drones, they are morally impermissible. They are not ethical, because the machines decide about life and death is not ethical, right? The machine can kill people. So if you start from different standpoints, actually you will reach some very different interpretations. The second problem is that they can conflict with each other in some concrete cases. These principles themselves just conflict. For example, privacy and data collection for health science can conflict. We know we should ensure all the users' privacy. When the patients go to the hospital, their health records should definitely be kept confidential. We need to ensure their privacy, their privacy of rights. But if we want to develop the health science, if we need to make some improvements on the health science field, then we have to do the data collection, right? We have to collect all the users' data, their health records, so that we can maybe find out some new ways to cure these diseases. So actually, these 2 principles just conflict with each other in the health science, in the healthcare field, and they can come into conflict in practice. For example, excellent diagnosis might still be preferable even if its reasoning cannot be explained. If such diagnosis use some deep learning models, then that still remain black box models. They will make some very crucial decisions. For example, they are used to do the diagnosis for the patients. They cannot be explained. The reason the decision cannot be explained. But even in this case, maybe we still prefer such diagnosis system because the performance is really good. Even though no one can explain that, but the performance is really good. And if we use such diagnosis system, we can like save the lives for the patients. In this case, it seems that we just miss such conflict. But actually, there are many dilemmas, many contradictory cases if we consider the principles. In this case, actually, we can introduce another concept, the interpretive label. Because whenever you are given principles, actually not only principles in AI, we know in our society, in our real world life, possibly we will just be given many policies, right? For example, when you enter the university, actually you have the university policies. When you select a course, actually we also have some course policies. And at the end, like your grades may just be decided by some grading policies. Actually, we have many policies, many principles, or the regulations in our daily life. But all of their similarities are there are some high-level texts. That means in order to understand that, we have to do some interpretations. We have to interpret what are these high-level principles mean. In this case, we will make efforts. This effort is called the interpretive label. Actually, in Chinese, it also has a famous translation in Chinese that is called 阐释性劳动, interpretive label. Yeah. So this concept was raised by David Graeber in the Utopia of Rules. David Graeber introduced the concept of the interpretive label. By definition, it's the differential between energy put into explaining an idea and the energy needed to understand it. Like when someone makes a policy, the policymaker should explain it, should explain the idea to the public. And still the public need to put some effort to understand such policy. And this is the differential between these two energies. And note that everyone interprets a given action or idea differently. Often you need to put work into understand what people mean. This can be literal. Literal means that, for example, when you listen to someone, the people may have some accents in speaking, and possibly the accents you are not so familiar with. In this case, you need to put some efforts to interpret the accents. This is one example. This is some letter that you have to interpret. Or more figurative. Here is an example. Suppose you have a friend. I guess maybe everybody has such a friend who are always late. When you make an appointment, for example, when you make an appointment that you should like go out to play, go out for dinner, but this friend is always late. Okay, such a friend. Of course, you can interpret that this friend does not respect you, does not like you, does not want to go out with you. That's why the friend is always late. But possibly there is some other interpretation. Possibly this friend is just have some very bad time management. Possibly this friend just comes from a culture that in their culture actually being on time is not some big deal. Like they can possibly the culture is just they just get late frequently. So it's not like they don't respect you, they don't like you, it's just they are coming from such a culture. So actually you can interpret the same action, the same behavior in very different ways, right? But before you know the answer, before someone can explain to you, you have to put your efforts, you have to guess why would this happen? What should be the interpretation? How should I understand this behavior? Why does this friend always be late, right? You have to guess, think by yourself. And the work it takes to do is the interpretive label. Of course, the examples I listed are just some very daily life examples. But this concept is most used when there is some hierarchy. For example, the hierarchy of power. And usually the hierarchy of power will bring the hierarchy of information. So that means in such hierarchy, different levels, you have different information. So in the Utopia of Rules, David Graeber wrote that within relations of the domination, it is generally the subordinates. Subordinates means that the people at some lower hierarchy level. The subordinates who are effectively relegated the work of understanding how the social relations in question really work. It's those who do not have the power to hire and fire who are left with the work of figuring out what actually did go wrong as to make sure it doesn't happen again. Right? Because they don't have so much information. They are in some lower level of the hierarchy. Then they have to do the interpretive label. And another example, for example, as students, you really care about your grading. And we have many grading policies in the university. In this case, actually, it's you, students, who put the most efforts to understand what are the grading policies, because they really affect you, affect your grades, possibly will also affect your future by affecting your GPA, of course. In this case, it's you that who puts the efforts to understand that. And this is an example of the interpretive label. And this would be the limitations, exactly the limitations of the policy of the principles, and that's why we introduce this concept. Because whenever we say, okay, about AI ethics, there are some principles, there are like a full documentation. With this documentation doesn't mean the AI model will definitely be ethical, because people need to put such interpretive label to understand what these principles mean. So still, it is nevertheless good to have such principles as some orientation points and evaluate solutions, but they are not perfect. Only having high-level principles is not enough, definitely not enough. The ethical principles for AI, they are not some checklists or boxes just to tick once and then you just forget them. There are some codes of behavior for AI systems, but most importantly for us, for humans. So it is we humans who need to be fair, no discrimination, and accountable to ensure privacy for ourselves and others, and also to aim at social and environmental well-being. So actually the codes of ethics are for us. Then the AI system will follow, because it's we humans who input our values, our principles into the AI models that we built. All right, then next let's see some areas of the AI ethics. So if we just do a very broad classification, we can see that there are mainly three main areas to ensure the AI models in production, their organization function ethically. The first is about data. In the data aspect, we already need to ensure the data ethics. And then it's the AI model fairness. And last, we still need to monitor and maintain the AI model to make sure they can just function properly in the future in a long time. Let's look at them one by one. First, data ethics. Data ethics means that we need to ensure that AI models function in a way that is fair, unbiased, and in customers' best interests. Starts with ensuring the data that feeds into them is collected, governed, and used ethically. We all know that the AI models, the machine learning models, they rely on the data, rely on the training data, right? What results you can get from a model depends on which training data you feed into the model. Basically, the model is always trying to learn the features from the training data. This means that we need to ensure that the companies secure the proper consent from customers before using their data and handle it in a secure way that respects their privacy. So the data already should involve with the privacy and the data protection of individuals who contribute their data. Second, about the data's representation. That means we need to take some proactive steps to address the data bias in those data sets and ensure the populations being analyzed, they are fairly represented in the data. Then the second area is about AI model fairness. After we ensure the data that feeds into AI model is relatively unbiased, then we still need to control the model itself. Like AI and machine learning ethics require the enterprises to ensure that those models are built in a way that ensures they make their decisions or recommendation fairly. We don't want the AI model to show some discrimination against any groups of people. And the third, about data model monitoring and maintenance. We know some machine learning models adjust themselves to improve their accuracy. Right, when you're building your neural network model, you adjust some layers, like change the number of nodes in some layers, then the accuracy will just change. Whenever you adjust your model a little bit, possibly the accuracy will also change accordingly. Then others means that they are not the one who develop the model, but they are the one who get affected by the model results, like the customers of an AI model. Then the others may just see their accuracy change over time due to changes in the data flowing into them in a phenomenon known as the data model drift. Data model drift, the results, the accuracy always change, but actually the users or the customer, they don't know what happened. They have no idea what is happening. Then, of course, they will raise some panic, right? They don't know what happens to their data. They don't know what happens to their own prediction and why the results always change. They don't know. They are not the one who developed the model. In this case, the enterprises must also ensure the AI models are effectively monitored and maintained to continue functioning as intended over time, instead of just letting the AI model flowing arbitrarily and cause some panic. All right, so above are the three main areas of the AI ethics. Next, we will specifically address a very important topic in AI ethics. One of the most important topic is called the AI fairness. So maybe let's first take a 5 minutes break. After the 5 minutes break, we will continue with the AI fairness. All right, so let's continue with the AI fairness. So the topic of enforcing fairness has become very important, in particular AI and the machine learning. So next we will address 4 questions. First, what is fairness in AI? And then why should we care about fairness in AI and machine learning? And then what kind of unfairness could there be? And then what causes unfairness? Let's start with the first question. What is fairness in AI? So when we're talking about fairness in AI, we are talking about the 3 aspects. The first aspect is that we need to develop the systems that are equitable and avoid perpetuating bias or discrimination against any individual or group. And the second aspect is that we need to consider the diverse needs and circumstances of all stakeholders impacted by AI use. Then the last aspect, actually the fairness extends beyond some technical concept. It's not only technical concept, it embodies the broader social standards related to equity. We know that fairness is not a concept in AI. Fairness is a concept in social justice, right? It just goes beyond such technical concepts. And we first have to know what is fairness in social justice, what is equity, equitable, all these things. Then we can know what does it mean in AI. Second question, why? Why should we care about fairness? Because currently, many things become automated by machines. For example, the employers select candidates by using the machine learning systems, and many of the companies actually they adopted the AI models to just filter the CVs to help with their recruitment. So these are very crucial decisions about any individual, about the applicants, and they are just decided by some AI models and machine learning models. And don't worry, at least as far as I know, the universities, they do not use the AI models to scan the CV and then to select the applicants to go into university. At least currently, most universities, they won't use such models. And like the LinkedIn and XMG, they use machine learning model to rank the candidates. After ranking the candidates, again, the companies can select the candidates, just rank from some AI models. Actually, the course in the US, they use the machine learning models to predict the recidivism. The recidivism means that the second crime within 2 years. So that is, if there is any people who conducted a crime once, they will use a machine learning system to predict whether these people will conduct another crime within 2 hours. That is called the recidivism. And if they use the AI model to predict, okay, such people has high potential to perform recidivism, actually this affects the decisions of the courts. It sounds like some pre-trial risk assessment and actually decide the different behavior and also the different legal decisions towards these crimes. Later on, we will see a case study on this one. And the banks, they use credit ranking system, which also use machine learning. So that is, if you apply a credit card in a bank, and then the bank, actually, they will just use some models to predict, okay, whether they should approve your application and how much credit they should give to you. For example, you are students, then possibly the bank will just give you some credit monthly just below 10,000 Hong Kong dollars. And Amazon and Netflix, they also use recommendation systems, and recommendation system, they are already the AI and machine learning models, right? They will predict what you like, what you would like to watch in the next, what you would like to buy, given all the buying history of you. Then just consider if these systems act unfair. Then the groups and individuals, they may just suffer from these decisions. We will see some unfairness examples. just give some case studies on like at which cases the unfairness just occur. Like this is the first example. The bias in text-to-image models. We use Midjourney as an example. Midjourney, like how many of you have used this one? But I think this Midjourney needs some subscription. So yeah, I guess maybe it's better to use some free generative AI model. This Midjourney is a popular text-to-image system that was released in 2022. Actually, the GPT also has some text-to-image model. So that is, you just give some prompts, text as prompts, and then it will generate some images. And then the people find that when prompted with an influential person, it generated most of, or even all images of older-looking white males. Older-looking white males, like I guess in this classroom, none of us is belonging to such type, right? Basically, that means the Midjourney doesn't consider us as some influential person. The influential person should just look like this, older-looking white males. And this is already some bias, definitely some bias. Like when considering who can be influential person, the AI just has some stereotypes and also use the biases to generate the images. And in a similar way, when typing someone who is intelligent into Midjourney, it will lead to 4 images of eyeglass wearing. So at least the AI has some sense that the intelligent person should wear glasses. Yeah, so like who wear glasses at least like we satisfy one feature. But still, the intelligent person generated by Midjourney, there are some elderly white men. Note that the last image here is particularly reminiscent of Albert Einstein. So basically, this is how the Midjourney thinks who are intelligent. And of course, this also reveals another ethic issue, that is the copyright. So actually, we know that when we ask the generative AI models to generate some images, this involves with the copyright issues frequently because they will just possibly generate some copyrighted material. This is the first example. You may say, okay, this example, yes, it indeed shows some bias, shows some unfairness, but it seems that it's still okay, right? It does not affect our daily life. It seems that it's just, okay, if we find that it's so biased, then we don't use it, it's okay. But what about some of more crucial decisions are made by AI? The second example, the COMPAS system. So this is a very famous article and a very famous study, a survey study in 2016. The article called Machine Bias. There's software used across the country. The country refers to US. The country to predict future criminals and is biased against blacks. So the system is called the COMPAS. Full name is the Correctional Offender Management Profiling for Alternative Sanctions. COMPAS is a case management and decision support tool developed and owned by the North Pointer, and now it's called the equivalent used by the US courts. They really use this model to assess the likelihood of a defendant becoming a recidivist, a rearrest within 2 years. And after the research studies, they found that the algorithm false positives. False positives in this case mean that the defendants who predicted to reoffend but who actually did not. The false positives were disproportionately black. So that means the model will just think that, okay, the black people, they tend to recommit the crimes, even though these black people actually, they did not. And in the meantime, the false negatives. So this case, false negatives means that the defendants predicted not to reoffend, but who actually reoffended were disproportionately white. That means even some white people, actually they will reoffend, but the model just predicts that they won't. So this is some obvious bias against black defendants in this COMPAS system. There is another general critique of the COMPAS system is that since the algorithm it uses are trade secrets, they cannot be examined by the public and affected parties. Basically, the public cannot audit the model, cannot examine the model, but just follow the decision of the US courts who use this model. And this may be a violation of the due process. And actually, this involves with another issue in ethics, that's the transparency. As we can see, usually these ethic issues, they are not singly occurred. Actually, they will just overlap with each other in some specific real-world cases. This is the second unfairness example. As we can see, this AI model is not only some toys. Previous text-to-image models, we maybe just treat them as some toys to play with it, but this model makes crucial decisions. It will decide like how many more years the criminal just stay at the jail. And this is just decided by a very biased model. Next, we can analyze some possible reasons for the AI model's unfairness. Exactly that is how the bias go into AI model. What is the source of the bias? There are many sources, of course. So we will just list a few examples here. Like maybe the main causes. First, human bias. We know that the data already reflects human decisions and biases. For example, if we use some machine learning model for the hiring decisions, usually the companies will directly use some previous hiring decisions in itself, right? This is how they get their data. Then the data from previous hiring decisions work as training data. However, this data already perpetuates some existing biases. For example, maybe in the history, the company just tends to recruit white people, or maybe just in history, the company tends to recruit males instead of females. And in this case, the data from all the previous hiring decisions already biased, and they will just perpetuate the biases to the future decision. Then we may ask that, could we reduce bias by measuring the employee success instead of the hiring decisions? This is one possible solution to address it, right? But note that if we use some model to measure employee success, that is after recruiting, how successful this employee will be in the company, it's harder to measure. And even though we can measure the employee success, still we know the institutional biases can impact the success. Because even the same company may provide different environments for different groups of people. And the people just meet with different resources, different environments. Some may feel that this is a very friendly company, but some may not. And this may all impact success. This bias is already from the human bias. The second source is the so-called negative feedback loops. Now that all these sources, the reasons, actually they correlate with each other. The negative feedback loops means that the data collected in biased fashion already, and then the future observations will confirm the predictions and reduce further contradicting evidence, which just cause such negative feedback loops. Here is an example. For example, the allocation of police attention based on the prevalence of crime. Like all the history records of the prevalence of crime may already have some bias. And then based on such prevalence of crime, the police may just decide allocation. For some districts, they will allocate more police because they think this district has like more criminal happening. And then after they allocate more police, of course there are more police, then they will be easier to find some new crimes. And this already caused the negative feedback loops. And after finding more crimes because of more police there, then this will just confirm their own predictions, even though they are biased, but still confirm their own biased predictions. And then without some future contradicting evidence, this causes a negative feedback loops. And then possibly they will just allocate more and more police there, and they will just find more and more crimes there. And another reason is the sample size disparity. Like the models for some minority group may be less accurate if the less data is used. For example, in medical studies, the race representation is really unbalanced. In the medical studies, most of the data are from the white people. And the Asian people is relatively less, and the black people is even less. They already have like unbalanced race representation in medical studies. Then that means maybe the drugs they developed after the medical studies, they will be most suitable for white people instead of for other groups of people. And this also has a relation with this reason, unreliable data. So data from minority groups is less reliable or less informative, which will cause that models may be less accurate for minority groups, which will then further cause that the beneficial interventions may be less available to the minority groups. For example, the inaccurate census in the predominantly minority neighborhoods and may just cause that the medical interventions with very limited diagnostic tools, they cannot benefit from these diagnostic tools because they do not have reliable data. Basically, when we are doing data collection, some group of people are already ignored. And then proxies. Proxies, actually this is a quite interesting reason. Like just now, we talk about many like the possible bias, right? Then some may immediately propose the solution that why not directly remove some features, like the sensitive features, gender or race. For example, when we are develop hiring model, AI recruitment model, or when we are use an AI model to predict crime, we just don't collect such feature, like we don't consider gender or race, just directly remove. This should be protected. Okay, the model does not use such sensitive attributes, but still the model may just show bias against these different groups of people because there may be other proxy features that are correlated with sensitive attributes, and the AI model is really smart, really powerful. They can still find out the relation. For example, in the case of race, it could be some other variable that are correlated with race, such as postcode, right? Postcode is that which restrict the people are living. Like in US, actually, possibly some specific restrict, they will just leave some specific types of race of people. In this case, even though the data removes the race, but such feature will be found out by considering another feature such as the postcode. And then they will selected by the algorithm, and then still the bias will occur. The last but not least possible reason for unfairness is the cultural unawareness. We know humans work in AI systems. The choices are made by humans, and sometimes these choices can create biases. Right? For example, the lack of diversity in the AI developers and data science teams might negatively affect people who do not fit the group of AI developers. Because the AI developers, if they are so homogeneous, if they are just basically the same type of data, then it's very possible that they may ignore because they just simply they don't aware of the existence and the possible limitations of other people. For example, I think race and gender, we already have like very many examples. And then consider some other dimensions. People who work in AI and data science, at least there are some like young or some middle-aged people, right? In this case, it's possible that the developers, they are not easy to consider some old people's needs, old people's necessities, because all the developers possibly they're just young and or middle-aged people, or the AI developer, they may just like they are very healthy people. In this case, they may just simply ignore because they simply don't aware that there are some disabled people, the people with disabilities, and in this case, they still, due to such cultural unawareness, they may just cause some unfairness in their models because the healthy people make some decisions which will also affect people with disabilities. So these are some analysis on the possible reasons for unfairness. And at the last, we will talk about a very classical concept in the AI ethics, the moral machines. Like, can machines make the moral decisions? Note that the philosophers and ethicists usually consider machines as not capable of making moral decisions because machines do not have their own intentions and the machines does not know what is the consequence. In this case, basically the machine cannot satisfy the requirements of the responsibility, and so the machine is not capable of making moral decisions. However, as an AI developer, we still need to try, right? We still need to make our efforts to make the machine possible to make some moral decisions. We can try to find some properties such that machines could act morally. And then in this case, the machines need to have at least first beliefs about the world. Like for each terms, actually, we can try to propose some solutions from the technical aspect to address. Like the benefits about the world, basically that's some knowledge representation, right? We can try to store the data as some beliefs about the world, like the common sense knowledge, and then we need to think about a way to represent this common sense knowledge so that the machine can know, can understand such knowledge. This is about some knowledge representation. And then pro attitudes, that's the intentions. It's very controversial. Some people think that machines will never have the intentions, but still, if we want the machine to have the intentions, maybe we can try to solve it, try to address it in some technical aspect. That is, we can try to define what is intention, or try to define what is some good intention. Of course, this may involve of the mathematical definitions. That means mathematically we need to define, we need to set a goal for the machine to achieve. And then the moral knowledge. Again, moral knowledge is about some knowledge representation. We can have, like, for example, some common sense knowledge as some graphs, or we can also equip with some hard rules to input this moral knowledge into the machines. And then the possibility to compute what consequences one's own action can have. This means that the machine should look at the future. The machine should know what should be the possible consequences, and they should understand what does the consequence mean. And if the machines have at least this thing, then they can be considered as some moral agents. But of course, each of them is not trivial. Actually, each of these requirements is somehow challenging, and still we have a long way to go to make some of the machines can make moral decisions. And here is an example. Actually, it's a dilemma we talked just now, the self-driving cars. This dilemma originates from the trolley problem, another very classical dilemma in the ethics. So we know the self-driving cars will come into situations where they have to choose between bad alternatives, for example, killing the passenger or pedestrian, like this figure shows. Suppose in some cases, the self-driving car can only have these two, of course, two bad choices. But the self-driving car just have to choose one of the consequences. Like if the self-driving car goes in this way, then the passengers in the car will get killed. But if the self-driving car just goes directly, straight way, then these 5 pedestrians will get killed. So of course it's very cruel, but still sometimes may just have to choose between these bad alternatives. Now how should such a car choose in such a situation? Know that because of its much faster reactivity, right? The self-driving car have much faster reactivity than humans. Humans may not have the response time to make the decision, but the car can do that. The self-driving car can do that. The self-driving car might be able to make the decisions when a human cannot at all. And some idea is that, of course, it's very cruel, it's very difficult to choose. Then maybe just ask ordinary people think what a car should do in such moral dilemmas. And then possibly after collection of lots of ordinary people's choice, we can use some collective wisdom to make the decision. And this is the motivation of this website, the Moral Machine website. So if you click into this Moral Machine website, yeah, basically you will find that it's like a small test. Like it randomly generates some scenarios for you to decide. Like if you start judging, then it will just give you, in total, it will give you 13 questions that you have to choose. Like what should the self-driving car do? And actually, you can also show the description. For example, in the left case, the self-driving car with the sudden brake failure will just continue ahead. And in this case, one dog and one cat will get killed. But in the right choice, this self-driving car will just cross this, and then one large woman and one female doctor will get killed. Yeah, it's very cruel, right? But still, like some cases, we have to face such situations. And then this moral machine website actually provides such a scenario for ordinary people to do such choices and to say what should a moral machine do in these cases. Actually, you can try this test after the class by yourself. After finishing the 13 questions, it will return an analysis report to you that which groups of people or which groups of animals that you preferably to save, always to save. So you can just do it after class. So know that the dilemma, even though we see that sometimes we have to face, but still the dilemma is really a metaphor. It's just a metaphor to highlight the ethical challenges. Just like the trolley problem, just a metaphor, not some real-world situation that you have to make the decision right now. It's just some ethical challenges that autonomous machines may encounter rather than aiming at portraying a realistic situation. So in other cases, of course, we don't expect, we don't hope the situations happen like this. All right, so that's all about the machine, moral machine. And at the end of this lecture, we still have a practice problem. And know that actually this lecture, Ethics of AI, is also in the final exam coverage. So still we will give you some questions in the exams, and you can refer to the practice problem here. And some very important concepts in this lecture will still be assessed in the final exams. All right, so any questions so far regarding the ethics of AI? Great. If no question, then very last a few minutes. Yeah, the final exam information. So the final exam will be held on December 13th from 12:30 to 3:30. We have two venues, like the AR system just returned these two venues for two lecture sessions. So you're L1, so basically you will go to LG1 table tennis room to have your final exam. Later on, we will release the seating plan so that you will know what seating number you will have. And the scope is just from introduction to artificial intelligence until the ethics of artificial intelligence. And all the materials, including like lecture notes, the lab exercises, and the programming assignments may be tested. And later on, I will also announce some detailed instructions and information about the final exam. Note that later on, we will also release an optional lecture. That's the introduction to reinforcement learning. This is an optional lecture. We don't have time to cover it, and this is not at the coverage. Basically, it's just for your interest. If you are interested in this reinforcement learning, you can refer to this lecture later, but it won't be in the coverage. And I think you still have like several deadlines to complete. PA2, Lab 8, and Lab 9, and possibly in other courses you have many other deadlines. So please take care and please manage your time properly at this very last week. And hope you all have good reviews, and good luck to all of your final exams and all of your deadlines. So see you in final exam. Okay. Okay. Thank you. Thank you. Thank you. And please take care in this period. I know like many of you like may get a cold. Like I also got a severe cold recently, so please take care. Okay, please stay healthy.